It's until the server is back on now, because you can't post the link. So I'm recording it, so it's gonna be great. Okay, so for this one, it was written in standard form. So then we know if it's written in standard form that that is the y-intercept. Right? So I just wrote it down there. So the y-intercept is at -6. So those are the coordinates. The coordinate 0 for x, and then the y value is -6. For the x-intercept, you have to make y equal to 0, right? So you're going to take the whole equation and make y equal to 0. So the whole thing equal to 0. Now, guys, you could have just used the quadratic formula from this line already. Okay, if you wanted to. That's perfectly fine. What I did was I divided through by 2. Right? So we see that 2 will go into all three of them. So the 2x squared divided by 2 is x squared. -4x divided by 2 is -2x. And -6 divided by 4 is -3. So I did that because then I could just factorize. Okay, but it's fine if you just use the quadratic formula right from that step. So I'm actually going to write it in for you just so that you can check. From this line, you could have said x is equal to -b, right? So -4. I don't think it's going to fit. Plus or minus, sorry, let me just move it to the spot where I have a bit more space. The square root up, can we remember the quadratic formula? What goes in the square root? Squared minus 4ac, right? So it's -4 squared minus 4 times 2 times c, which was -6. That's now if you use the quadratic formula right from the start without still dividing through by 2. And then that all is over 2a. Right, so 2 times 2 for this one. And then I'm sure you would have gotten the same 2 answers. So you type this in with a plus, and you go back, you change the plus to a minus, and you get your 2 answers. Okay, so you would get 3 and -1. For the turning point, we use that formula. Remember, -b over 2a. Right, we did that in class on Friday. So for the turning point, remember when your equation is given in standard form, you can't read the turning point off. You need to use a formula. So x is -b over 2a. So -b, which is -4 there, over 2a, which is 2. Alright? When you type that into the calculator, you get an answer of 1. So that is the x value of your turning point, 1. You then need to take that x value and sub it back into the original equation, okay, the equation that they gave you, to get the y value of the turning point. Alright, so 1 -8. So those are the coordinates of this. Alright, any questions on the calculations? Okay, let me just show you what my graph looks like. So I use one thing as 2 units here for the y value. But remember, guys, we don't really worry about the scale as long as you have your points and you label them. Okay, so yours might be a bit like longer than mine. That's perfectly fine. And then just remember, try and not make it too pointy here at the end. And we're not super strict about that, but you obviously can't draw like a triangle. Okay, in terms of marking, you would get 4 marks for this. 1, 2, 3, 4. Possibly a 5th mark for shape, but yeah, they don't really want to give 5 marks for a parabola, but they might. But guys, I think I told you this last time already, but I'm just going to say again, if you have to draw a graph, a parabola, and you don't have enough time or you can't remember how to, remember that we look at our a value, right? The number in front of x squared to tell us what the shape of this graph is going to be, right? So because that's positive 2, it's an upwards facing parabola. So if you can't calculate anything, say you hit a blank, you don't know what to do, but you at least remember that, okay, that's positive 2, so it needs to be an upwards facing parabola. Just draw that shape, right, with no value. Just do like this thing on a computer page. Okay, you'll get 1 mark for that. And you'll get the shape mark. Okay, even if you don't have any coordinates written down. Mark that you could at least get. Any questions on this one? So now the next one was a bit iffy, but I'm actually glad that it came up because we didn't discuss it in class. Let me just quickly put this here. So now for number 2, it was written in turning point. Okay, so you all could have at least found the coordinates of the turning point, right? Remember that this one, the coordinate in the bracket, always has a different sign from what it has in the point. Right, the x coordinate is x plus 1, it's going to be -1. That's just like when we did the trig graphs. When we had an x plus 30, we moved 30 degrees to the left. Okay, so those two signs will always be different, but then for the y, it will always have the same sign. Okay, so if it's a plus 4, it's going to be positive 4 in the first point, the ordinate. Now for the y-intercept, like I said, you can't just say, okay, the constant term is the y-intercept, all right? Remember, this 4 has to do with the turning point, not the y-intercept. Okay, so you have to make your x value equal to 0. In the equation, 2 times 0 plus 1 squared plus 4. You can just type that into the calculator. You don't have to show that. I'm going to write it down, and then you'll get 6. Okay. Now, when it gets to, or when it's not to, finding the x-intercept, you actually couldn't solve this equation. Right? I don't know if you guys noticed that. So if you did it exactly like we did in class, where you just move that 4 over, now because it's a plus 4 on this side, it has to be -4 on the other, right? And then you'll divide by 2, so you'll say -4 divided by 2 is -2, but now we have to move the square. You're supposed to do a plus minus square root. Okay, can you get the square root of a negative number? No, okay? So there, when you get to this step, you should realize, oh, I actually can't work that out. There's no answer there. No solution. So that means that there are actually no x for this graph. Yeah.
You only put the plus and minus on that side. Even.
When that number is in the middle, the exponent will be.
What I can do
No, it's just this. Yeah, the exponent you do. You take. Okay, so now what do we have, guys? We can't find x-intercept, so we only have 2 points. Is that enough to draw a parabola? Only 2 points. No. Okay. You remember from what we did before the holidays, you need at least 3 points. So for the previous one, we found 4 points, which was nice. Okay, that's more than enough. But now we can't draw a parabola if we only have 2. So what you would have done in this case, possibly, is you could have just drawn your Cartesian plane and just plotted the 2 points that we had. Okay, just ignore that for now. Those were the only 2 points that we had calculated. That was our turning point and that was our y-intercept. And guys, do you remember from the graphs that we did before the break? I always said you needed the middle point and then 1 point on either side. Right? Do you remember that? I'm just quickly going to go back to some of those parabolas that we did. So this was number 4 from when we did parabolas at the beginning, before the break. Here we also tried to find the x-intercept and we couldn't solve for it. Okay, so there were no x-intercepts. So then I said, now you must choose a negative and a positive x value. You guys remember that, right? So that you have 1 point on either side of the turning point. So our turning point was here, where x is 0. So we chose x is -1 and x is positive. Okay, we need to apply the same concept to the parabola that we have now. We have the turning point and we need 1 point on either side of the turning point. Okay, it's a little bit more difficult because the turning point is now not at 0. Right? Where is my turning point? At -1. So we have this point and we have that point. We need a point on the other side of the turning point now. Right? So these are the 2 points that we calculated. We have a point on the right-hand side of the turning point. So we now need to choose an x value on the left-hand side of the turning point. Okay, so it's a bit more complicated, right? Now what I did here, I looked at x values. I checked. I saw, okay, my turning point is at -1. And then I have another point at 0. right? So I just went, that's 1 unit. You see, 1 unit to the right. So I just went 1 unit to the left. Okay. So I chose to sub in -2. But you actually could have subbed in any point on the left side. Maybe you wanted to do -3 or -1.5, whatever. But you're going to have to sub in an x value on the other side of the term from the one that you have. Okay, I'm going to write that down now. I didn't actually write that down. So I'm just going to write underneath. Maybe you guys just want to copy the graph quickly. Just draw the graph and then we'll write that underneath. And maybe I'll just do it on the side. And then move this graph a little bit. And then I'll write it next to it. And this is important, guys, because if you just have the 2 points, I mean, you'll get a mark for each of them, right? You can still get 2 marks. And then you can kind of figure out that if that's the turning point, then the shape needs to look like that, right? You know what a parabola looks like. So you can kind of still get your shape mark if you just draw the other half of the parabola there, even without another point. But if you want to get full marks, you're going to have to find that third point. Okay, so I'm just going to write here. Choose an x value on the left-hand side of the turning point. And sub into the equation. So I decided to sub in x equals -2, and then I got my y value. By what that equation was. 3 times -2 plus 1 squared plus 4. Mhm. Yeah, I hope that makes sense, guys. Sorry, let me finish this one. I think 4. Realize if I'm looking at the equation. But guys, like I said, you can still get 3 out of 4 for this graph. Okay, even if you didn't sub in negative. Just realize, because we know that -1 is the turning point, right? We calculate, we read it all. So you know that if it looks like this on the one side, it has to look like that. Okay, so don't stress about that third point too much. Obviously, it's great if you can do it, but you can still get 3 out of 4. Yeah.
What about the axis?
Yeah, so you don't have to draw that in, but we can draw it in quickly. Where do we think the axis of symmetry for this graph will be, guys? At -1, hey? At x equals -1. So you can draw in that line if you want. Normally, you only have to draw that line in if they ask for it specifically. And then I'm just connect myself to quickly. And remember that if you are drawing it, you need to just label it as well. So just write x equals -1. And then just quickly for practice, guys, let's write the domain and range of this graph as well. Again, you only have to do that if they ask for it. But let's just quickly write that down. So underneath here, domain. Remember, domain is all the x values, right? What do we think? we're looking on the x-axis, along the x-axis, it's going to keep going, right? So negative infinity 2, also going to keep going, there's an arrow there to positive infinity. Okay, so remember there are two ways in which you could write that. You can say x is an element of negative infinity to positive infinity, or the quicker way of writing it would just be to say, oh, sorry, x is an element of real numbers. Okay, and then the range. Range, remember the y value, so you look along the y-axis. We have our turning point. We're always going to have to look at the turning point for that, right? So we agree that the turning point is the minimum point in this case, right? So y has to be all values greater than or equal to, what is y value of this point here? 4. Okay, so you're going to have to say y must be greater than or equal to 4. Or you can write it like this, y is an element of 4 to infinity. Okay, we are done with parabolas for now. We're going to do some hyperbolas today. So I would like you to write a heading drawing a hyperbola, like we did for parabolas the other day. Okay, guys, good news. Hyperbola only has one form of the equation. All right, so the parabola is the only one that has 3. So hyperbola is more or less complicated because of that. Okay, so we call it the standard form, and it is y equals, now it's a little bit different from the one that we did before the holidays. We have a more complicated denominator of this fraction. Yeah. Okay, but guys, all that this p value now changes because the ones that we did before the break, I don't have to write this down, but those ones were like this, a over x plus q. All right, so we didn't have that p value. Can anyone remember what q was? Asymptote. So the y asymptote, right? You're almost there. So q was the y asymptote, the horizontal asymptote. Guys, that's still the case now. Okay, so we can write that in. Q is going to give us our horizontal asymptote. And that asymptote is going to have the equation y equals q. And it's going to look like this. Okay, horizontal is like that. So that was the q value. Now the p value is going to give us another asymptote. Right, so in the past we had hyperbolas with only one asymptote, a horizontal one. Now we're going to have a vertical one as well. All right, and the vertical asymptote is going to be x equals p. Okay, so let's write that there. The VA now, the vertical asymptote, is going to be x equals p. Again, guys, do we see that in the equation? It's x minus p. But the asymptote is x positive p, right? So always with the x, the sign is different. Okay, for turning point form, the x sign in the bracket was different from the x value of the turning point. Here, with the hyperbola, the sign in the denominator is different from the sign of the actual asymptote. You'll see now when we do it. Okay. And a vertical asymptote is going to look like this. Vertical is going to be a vertical line. It's going to cut through the x-axis like that. Guys, if you don't know how to draw hyperbola at all, if you just draw your two asymptotes, you get 2 marks. Okay, you get 1 mark for the horizontal asymptote, 1 mark for the vertical asymptote. You can just read them from the equation. Okay, so it's actually quite easy to get 2 marks straight away for hyperbola. All right, other stuff, obviously we need to calculate the y-intercept and the x-intercept. Okay, so those are the only other 2 things that we need to worry about. So y-intercept, we are going to do that by making x equal to 0 in the equation. So you're going to take your equation, you're going to type it into the calculator, instead of x, you're going to put a 0. Okay, that's it. That's going to give you the value of the y-intercept. For the x-intercept, we're going to make y equal to 0. Right, just like we've been doing so far. So you're going to make y equal to 0 and then solve for x. So finding the x-intercept is a little bit more complicated. You can't just type it into the calculator. You're actually going to have to solve an equation. Okay, now guys, do you remember that a hyperbola consists of 2 parts, right? We need 1 point on each part. Okay, sometimes it's going to work out nicely. Sometimes your y-intercept is going to be on the 1 part and your x-intercept on the other part. That's fine. All right. But if both of these points are on the same part, you're going to have to sub in an x value to get a point on the other part. Okay, so we'll look at that with an example. Not that bad. I'm just going to add here. You have to plot one point on each part, or at least one, I suppose. It's fine if you do more than one, but you have to have at least 1 point on. Okay, other things for hyperbola, we will look at it when we're doing some graphs. But a hyperbola actually has 2 axes of symmetry. A parabola only had 1, a hyperbola has 2. And they do sometimes ask it as like an extra question, right, on the equation. Okay, so there are 2, like I said. The first one is very easy. You're going to say y equals. You're going to take your denominator and your plus p, right? So it's going to be the whole denominator, x minus p, and then whatever the plus q is. And then guys, because remember p and q are going to be numbers, right? So these are going to be 2 numbers. You just have to add them together or subtract them, whatever they are. Okay, you'll see when we do example. So that's for one axis of symmetry. The other one is very similar. The only difference is you need to put a minus in front of your denominator. Then multiply that minus in. And then add your q value as well. Sorry, I'm just making one more time. Yeah, I hope this one. Right, we're going to do an example, maybe 2. We'll see how much time we have. Okay, now guys, obviously when you are doing this test program, they're all going to be mixed together, right? So we'll give you like one or two graphs to draw, maybe. Maybe we'll just give you some graphs and an answer question, but we'll get to that still. But you need to be able to look at this equation and know that it's a hyperbola. All right, can anyone remember what was like the identifying factor around them? You're always looking at where the x is, right? So for a parabola, there's always an x squared. For hyperbola, the x, ooh, that's a bit big. The x is always in your denominator. Okay, so maybe let's just write that there. Obviously, we know this is a hyperbola because we're busy with hyperbolas, but in a test, that might not be the case. All right, so x in denominator, therefore hyperbola. Okay, I suggest that you first write down the two asymptotes because you're first going to have to draw those, right? So we remember that our asymptotes are given by the number in the denominator and our Q value. Okay. Guys, you don't even have to remember which one is which. You don't have to write horizontal asymptote, vertical asymptote. You can if you want to, but it's not very important. Okay, the x asymptote is given by the x, the value here next to x. Okay, and like we said, the sign in the equation is different from the actual sign in the asymptote. So this one is going to be our vertical asymptote. So I will write VA then. Like I said, we're not going to take a mark off if you don't write VA. So you just write asymptote. Really matter. Now, because it's an x plus 1, it's going to be x equals -1. Okay, I'm going to add here different sign than in equation. Okay, the other asymptote, the horizontal asymptote, is given by the Q value. And guys, you can think of it in this way. The y and the 3 are kind of like on the same level, right? The x and the 1 here are on the same level, so they go together. And then the y and the 3 are on the same level, so they go together. Okay, so the other asymptote is y equals 3. That one has the same sign, guys. Are you noticing a pattern? The x always has a different sign from each equation, right? Like we have with the turning point and with trig graphs when we're thinking back to how it's shifted. So this one with the x asymptote is also has it. Okay, maybe we should just add the same sign. Guys, sometimes even a question, right? Sometimes they give you the equation of the graph and then like question 1.1 will be write the equations of the asymptotes. Right, and then you just write those two equations. Okay, next up, y-intercept. I'm just going to write again that for the y-intercept, we make x equal to 0. We're going to say y is equal to, now we're just taking our equation and instead of x, we're going to put a 0. So it's going to be 6 over 0 plus 1. And then plus 3. Now 0 plus 1 is just 1, right? So we actually have 6 over 1, which is 6 plus 3, which is 9. So the y-intercept of this graph is 0, 9. Okay, for the x-intercept, we have to make y equal to 0. Yeah. Okay, now guys, this is the part that's actually the most complicated of the whole hyperbola process. It's finding the equation. Okay. So what we're going to do is we're going to take the equation 6 over x plus 1 plus 3, and we're going to make it equal to 0. And now we need to solve for x. Okay, it's not super difficult, it's just it has multiple steps. Yeah. So first we need to move this, yes. And then we might have to do some more work on that. Okay, so the plus 3 we're going to move, it's going to become negative. Okay, so we're going to have 6 over x plus 1 equal to negative 3. Now we need to multiply this x plus 1 out of here. Okay, so I have a negative 3 there already. So what I'm going to do is I'm going to leave my 6 like that. And then I'm going to say negative 3. And I'm now timesing that by x plus 1. Right? On the left-hand side, guys, we're dividing by x plus 1. So when we move it, we have to do the opposite operation. We must times by x plus 1. Now, if you can maybe decide if you want to multiply that negative 3 into the bracket, that's fine. You can do that. Okay, but what you can also do, which is actually quicker, is you can now move this negative 3 over to that side. Right? So what am I doing with negative 3 here? Multiplying. So what's the opposite of multiplying by negative? Divided. Okay, what's 6 divided by negative 3? Divided by, hey? Negative 2. Okay, I'm just going to make a little note here. Where did this come from now? I said 6 divided by negative 2. Okay, you see why that's sorted out? Now all we need to do is move this 1 over. Okay, what is the opposite of adding 1? Subtracting 1. So what's negative 2 minus 1? Negative. You can write negative 3 is equal to x, or you can write x is equal to negative. So our x-intercept is negative 3. Okay, now guys, once you've done this calculation, you probably aren't going to know where your points are on what part of the hyperbola. Okay, so once you've done this, I want you to draw everything that you have. You're going to draw in your horizontal asymptote, which is the x asymptote, right? The y asymptote, sorry. Y equals 3. I'm going to do it with you now, just to remind you. But at y equals 3, you're going to draw in your x asymptote, which is new. We haven't had an x asymptote before. Then you're going to plot your 2 points. If you have 1 point on either part, that's fine. I'm just going to draw your part. Okay, if not, I'll show you what you have to do. Okay, so let's draw this together. We need to draw our y-axis quite high up because our y-intercept is at 9. Okay, so let's see if we can just figure that out. I always, if I have a point at 9, then I'll normally go to 10. Okay, just want that. I think my y-axis will go to 10 at the top. And let's do it kind of like word that I'm looking for, symmetrical. So how long that is now. So I'm doing 1 line for 2 units. Otherwise it's going to be huge. Okay, we don't want to do 10 at 10. So maybe go up to like 5 and 5 at the bottom. Don't know if I did that now. And then for our x-axis, we need negative 3. So, so guys, in a case of exam, if we're asking to draw a graph, we do usually give you that. Let's talk about this bit too much. It's a bit skew, but it's just because I've lifted this. So when you are ready, you can draw in your asymptote. So remember the y asymptote is at 3. So what that means, guys, is it's going to cut the y-axis at 3. So you need to go to your y-axis, which is this one, and you're going to go to 3. So now I said I'm going to use one line as 2 units. So that will be 2. So 3 will be like kind of there in the middle. Okay, and you're going to draw a dotted line going through y equals 3. Right, just a straight line there. I'm going to put arrows on either side. And I'm going to make mine dotted just now. Very important, guys, you have to label it. Okay, if it's there but it's not labeled, it's not going to get marked. So on either side of the graph, you can decide you're going to have to write y equals 3. Okay, you also can't just say 3, you have to say y equals 3. Okay, you have to write the equation of that one. So that is your y asymptote. There we already have one mark, guys, just for drawing that line. Okay. The x asymptote was at -1. Yeah, at -1. So that means that you're going to draw a dotted line that cuts through the x-axis, this one, at -1. Now I'm going to use one line for 1 unit on the x-axis, but you can obviously decide. So you're going to draw your line going through x equals -1. Put your arrows on either side. And again, very important, you have to label that line, either at the top or the bottom. You can decide where you have more space or where you think it will look neater. Okay, there we have 2 marks, right? And we haven't actually drawn either yet, right? We just drawn line. Okay, next you're going to plot your points. So we have 2 points. We have a y-intercept at 9. So I'm going to go 2, 4, 6, 8, and then 9 is the okay, and my other point is the x-intercept at -2. So -1, -2, -3. Do I have a point on each part of this hyperbola? Yes. All right. Remember, we're going to draw one part in this kind of block here and the other part in that block. All right. All you now need to do, guys, is you need to draw your graph and remember just kind of make the shape so that it's going towards the axis. We'll do it when it's next to us. And my top part is a bit wonky, okay, but something like that. And then obviously you need to label your points as well. You won't get marks for the points if they're not labeled, so that's very important. Okay, guys, again, 5 marks. We can put the mark allocations in here, 1 for each asymptote, 1 for your y-intercept, 1 for your x-intercept, and then 1 more for shape. shape this meaning that it's a curve. Okay, and it's going towards the aspect. Now guys, if we didn't have a point on each part, I'm just going to write down what we would have had to do there. For the previous ones, what we did was, again, we looked for a point on either side of the y-axis. Okay, so I'm just going to go back with you to our previous note. Yeah, so here, this is the note that we did last term. So there was the standard form. Then we said always plot at least one point on each part. So we would calculate your two intercepts. And then I say that if you need more points, choose a positive or negative x value, depending on which half you need a point for. Okay, so again, we're going to look at which half we need a point for. But now it's not as straightforward as just choosing a negative or a positive x. Now what we need to do, say we only had that point, right? Say we didn't calculate the y-intercept. We're supposed to do okay, but say we didn't have the y-intercept, okay? Say we only had that point. Then you would need to realize, okay, I need a point on this half. Now guys, it doesn't matter whether it's at the bottom or the top. What matters is that it's on the right-hand side of this asymptote. Okay? Do you see that the one half of our hyperbola is on the left-hand side of the asymptote? The x asymptote, right? X equals -1. That half is on the left of x equals -1. The other half is on the right of x equals -1. So that's what you're going to look at, right? You're going to look at the x asymptote. You need one point on the left of the x asymptote, so a point that is smaller than -1. Okay, the x asymptote is at -1. So if you need a point on this half, you're going to need to choose any x value that is on the left of -1, so smaller than -1. I'm going to write it down now. But if you need a point on the other half, you need a point on the right of -1, so a value that is bigger than -1. Okay, so like 0, maybe 1, maybe 2, any x value that's bigger than -1. Okay, so I'm going to make a note of that now. Maybe make a little arrow going from your asymptote here. You need one point on either side the x asymptote. Is for one point, let's say x smaller than -1 and 1 point the x value bigger than -1. So that -1, it obviously will change depending on where your asymptote is. So whatever your asymptote is, you need one x point bigger than that value and one x point smaller than that value. And so you might have to choose one if you don't have a point. So it will come up in a more top. Okay, we have 10 minutes left, so there's not enough time to draw another one. I'm going to give you one to do for homework, and then tomorrow we'll practice some more. Okay. So, are you all done copying this out? Okay. Okay, so this is now classwork turning into homework if you don't finish. Okay, that's the graph that you're going to draw. Guys, the fact that that now is a -3. The only thing that changes is if we're looking back to the previous example, it was +3, right? So we had a y-asymptote at y equals 3. This y-asymptote is going to be at y equals negative. Okay, that's all that changed. All right, you can start working on that now. You might be able to at least do all your calculations now. Maybe for each of the